In this lecture, we will discuss simple random sampling. Let's first review some concepts. Population means the collection of all individuals of interest. The individuals can be people or can be anything else that is under study. It depends on the purpose of your study. A sample is a set of selected individuals in the population. For sampling, we mean a process of selecting a sample. A representative sample is a sample whose relevant characteristics resemble those of the population under study. Notice that the major goal of inferential statistics is to infer the population based on a sample. In order to make sure that the process is successful, a key is that the sample should be representative. It is easy to understand. For example, assume that your population contains both gender, males and females. However, if your sample contains only males, it is unlikely that the result you get based on this sample can be reliably generalized to the whole population. In this case, we may say that your sample is biased. Let's look at a real story about the 1936 presidential election. The Literary Digest conducted an opinion poll and predicted that Alfred Landon would win easily over Franklin Roosevelt. However, the truth was that Roosevelt won by the greatest landslide in the history of presidential elections. What's going on? The major reason is that the sample is not representative. The sample was obtained from people who owned a car and had a telephone. In 1936, that group included only more wealthy people, and historically, such people tended to vote Republican. Another issue is that the response rate was very low, smaller than 25%. The low response rate leads to non-response bias. Basically, the data were not collected from the originally targeting sample, but from the people who were willing to respond. Because the responding people and the non-responding people may have quite different opinions, the result was misleading if the conclusion was drawn based on the people who responded. In this case, London supporters were more willing to respond. The sampling bias and the non-response bias combined together lead to the wrong prediction. Simple random sampling is the simplest sampling scheme. For simple random sampling, each possible sample of a given size is equally likely to be selected. A sample obtained by simple random sampling is called a simple random sample. Sometimes we need to distinguish scenarios with replacement and without replacement. For sampling with replacement, after we draw an individual, we will put it back before we draw the next one. In this way, a member of the population can be selected more than once. For sampling without replacement, after we draw an individual, we do not put it back before drawing the next one. So in this case, a member of the population can be selected at most once. In this class, we mainly deal with simple random sampling without replacement. Human judgment is likely to be biased. When we want to choose a sample, we usually need to use some objective tools. A random device can be used to help us select which members of the individual will constitute the sample. Tossing a coin is the simplest way to generate a random outcome. To decide whether to include an individual to a sample, we toss a coin. If we get a head, count the individual in, otherwise exclude this individual from the sample. In addition to tossing a coin, we may also use a random number table or random number generator. Let us try to draw a simple random sample. The top 5 state officials in Oklahoma are governor, lieutenant governor, secretary of state, attorney general, and treasurer. Now, let us draw a simple random sample of size 2. Here, we will draw without replacement. A possible strategy is that we prepare 5 paper slips and write each of the 5 officials on each slip. Then we mix those 5 paper slips together and then randomly draw one slip and then draw another slip. By this way, we draw a simple random sample of size 2. In this example, there are in total 10 possible samples we may select from. These 10 possible samples are listed in the bottom. Each parenthesis indicates one possible sample. For example, the first parenthesis indicates a sample consisting of governor and lieutenant governor. If we check the definition of simple random sample, it says each possible sample is equally likely to be selected. This sentence means that we may equally likely select any one of the 10 possible samples. Notice that it is different from each of 5 state officials is equally likely to be selected. The word equal likely to be selected in the definition is referred to the sample, but not individual. When the size of the population is small, we can prepare paper slips. If the size of the population is large, we need to use a different random device. This is a random number table. In this table, the digits 0 to 9 are randomly arranged. If we need a random number, we may choose any position and begin to read. Let's illustrate how to use this as an example. Suppose one professor wants to randomly select 15 out of the 728 students enrolled in his class for an interview. He can draw the sample using a random number table. First, number the students from 1 to 728. In this way, if we pick a number, the corresponding student is selected. Then we pick a random starting point in the table. For example, we can place the table on the desk, close eyes, and put a finger on the table. So we pick one random starting point. Then we read the table and start recording numbers. In this case, the maximum number is 728, so we need 3 digits. So we read 3 columns together, discard the numbers beyond the range of 1 to 728, and also discard duplicate numbers, if any. If more columns are needed, we will move over to the next 3 columns and go up. Let's look at the table. Assume that the starting point is 069, which is highlighted by the red circle. Hence, the first random number selected is 69. We move to the next row. It is 988. Because it is too large, larger than 728. So we skip this one and continue to the next. The next one is 386. Good, we write it down. The next one is 539. It's okay, we write it down. We will continue until the bottom of the table, which is 178. Right now, we do not have 15 numbers yet. Then we moved on to the next 3 columns. Instead of going down, we are going up. We can see that the bottom row in the next 3 columns is 849. It is larger than 728, so we skip it and keep moving up. The next number is 578. Good, we write it down and keep moving up. The next one is 404. Now we've got 50 numbers and then we stop. This is how we use a random number table to select a random sample. Sometimes we may also use a random number generator. Many calculators can generate a random number. Many computer software can provide a random number generator. When you are sampling using such a random number generator, just make sure whether you are sampling with replacement or without replacement. If you want to do sampling in Excel, first select Data Analysis toolpack. Then select Sampling. In the pop-up window, specify input range, and then select Sampling Method as random. Then type in the number of samples you want, and then specify output options. Click OK. Excel will draw a random sample for you.